Morning, class 7th. So from today I'm gonna start, today I'm gonna start your chapter number 4, which is heat. If you think about heat, then let us take an example that you are sitting or you are in a kitchen, and there is a pan which is on the gas stove, and all of a sudden you just touch the pan, and then you find that it is very hot. Okay, so what happened is actually you felt that that object is hot, means its temperature is higher. So that is actually the energy of heat. So heat is basically a kind of energy which travels from the region of a high temperature to the region of a low temperature. In that sense, if you see that some objects are cold and some objects are hot, that depends on the thing that from where to where the heat is traveling. So heat always travels from the high temperature to the low temperature. So if your body is higher than the outer one, then you will feel that object cold, and if your body is colder than the outer one, then you will feel that object hotter. So depending upon that, we decide that the objects are either cold or hot. Now let us see, if I'm talking about the temperature. Then what is temperature? Temperature is basically the degree of hotness or coldness, or it is a kind of the scale. It is a kind of the numerical value which is which decides the flow of energy, or it is the what you say, it is a kind of a scale by which we see the objects are how much hot or how much cold these are. So for measuring the temperature, we have different kinds of the thermometers. Thermometer, and then when you feel ill and you visit a doctor, then that doctor uses a kind of glass tube for you, and that glass tube is actually known as thermometer. So we have basically three kinds of the thermometers. One is mercury thermometer, clinical thermometer, and the laboratory thermometer. Now let us see what is the difference in their structure. Thermometer is same as this one is visible. It is same in all the cases, but difference is that basically there is a kind of glass tube, and inside that glass tube there is one small, means there is one more narrow tube which is known as capillary tube. And inside the capillary tube, the one substance is filled with in the bulb of the bulb is the means this tube has an extension which is known as bulb. And in this bulb one substance is filled which is known as mercury. Okay, and in that on that glass tube, it is sealed from outside and it has some markings. Okay, and these markings are actually the one which can be in degree Celsius or in Fahrenheit or in degree Kelvin. So in mercury thermometer, the substance which is filled inside the capillary tube is known as mercury. So it has 180 divisions, and on Celsius scale it has only 100 divisions. There are 2 points in the mercury or any of the thermometers. One is known as the lower fixed point, and second one is known as upper fixed point. Lower fixed point and upper fixed points are basically the point at which the water changes into the ice or the water changes into the steam, that we will discuss later on. Now see, there is one more kind of what you say, a thermometer which is known as clinical thermometer. Clinical thermometer is the one which is used by the doctors to see the temperature of a patient. It looks like this, and it has temperature which ranges from 35 degrees Celsius to 42 degrees Celsius. And and if we talk about the normal temperature of the body of a human, then it is actually 37 degree Celsius. So if it is above than that, then you are having some kind of fever, or some kind of high temperature, means there are some problems in your body. So for that, to measure the temperature, you have seen that doctor uses this in this manner. They put it under your tongue, and after some time they take it out, and they see the temperature. And that actually the mercury level is seen, means the mercury rises. The basically the principle of the thermometers is that some metals like mercury, when it is heated up, when it is provided with the heat, it rises. So in the same manner, when the thermometer is kept in your mouth, its mercury level rises because your body temperature is high. On the point where it stops, in means there are some parts are given there, and the point where it stops is this, actually it is your temperature of the body. So what precautions you must take for if you are using a clinical thermometer? First of all, it should never be broken, because mercury is poisonous, then you will die. And it means always use it by using a jerking movement, so that the temperature of the thermometer comes to the normal mark, that is 35 degrees Celsius. And if you are using it anytime, or then you must wash it before using it and after using it also, because it will lower the temperature also, and it will be safe for use, because many other means it if you are putting it in a mouth of someone, germs can attach on the bulb. And you must not use the means you must not hold the thermometer with the bulb. This is the bulb, because here the mercury is filled, and if you are using this one, so what will happen, that this means because your body temperature is varying, so you have taken patient's reading, and if you are holding it from here, then maybe because your temperature is low, so the temperature will fall and you will get a wrong reading. So these things should be kept in the mind before using a thermometer, any kind of thermometer. And there is one more kind of thermometer which is known as digital thermometer, which you see nowadays. There are thermometers which are digital, means their numberings are digital. If you put it in the mouth or anywhere, they will give you an electrical, means this computerized kind of, or digital kind of the numbers on that. This is not more reliable, because sometimes these digits may vary. Then laboratory thermometer is basically the one in which it is used for the laboratory purposes. Its reading ranges from the minus 10 degrees Celsius to 110 degrees Celsius, because in laboratories, sometimes we have to measure the temperatures less than 0 degree. So in that case we use this one. So here two things are used. There is mercury is filled as well as alcohol is filled. Mercury and alcohol both rise, and in so that we have the temperature of different category. Other than that, you will see all the structures are same, as in that in this lower point is minus 10, and upper point is 100 degree. Okay. So if you are the same kind of the precautions you must use it should not be broken, it should be covered by all the sides. And these are the same precautions which we need to have when we are using any kind of the thermometer, like the mercury or the laboratory thermometer. There are some advantages of using a mercury thermometer. What these are: basically, the mercury is a conductive liquid. That is why it means it is going to stop at exactly the same point where the temperature rises, and it never comes out of the glass because it is non-sticky, and means when it is rising, it rises in a proper way, and it boils at these temperatures or melts at the temperature. So basically, in that case, means the mercury is not going to come out from the thermometers. Then there are temperature scales. Temperature scales basically to measure the temperatures. Like if you are measuring a cloth, then you have centimeter, meter, and all that. For length, we have different kind of the scales. In the same manner, we have the temperature scales. Mean we have different types of the units to measure the temperature. Then in the first one, it is Celsius scale. It was given by Anders Celsius. He is the scientist who has given this Celsius scale. On this Celsius scale, there is one upper point is 100 degrees Celsius, and lower point is 0 degrees Celsius. So in if it I am again that is saying, if it we am talking about upper point, means the point at which the water steams, the water becomes steam, is known as the upper point, or you can say that it boils. The water boils at 100 degree Celsius, and the lower point is the one at which the water becomes ice. This point is also known as ice point. On the other hand, we have Fahrenheit scale, which was given by David Fahrenheit, and it has lower point, that is 32 degree Fahrenheit, and its upper point is 212 degree Fahrenheit. And if we are talking about Kelvin scale, then Kelvin scale was given by William Thomson Kelvin, and it has the upper point which is 373 degree Kelvin, and the lower point is 273 Kelvin. So basically, if I talk about the unit SI unit of temperature, then it is the Kelvin, which is the SI unit, and other units are actually interchangeable. See, this is the formula to change the units from one to other. If you have a unit which is in Fahrenheit, then it can be converted into degree Celsius by these two formulas. Fahrenheit can be converted into degree Celsius, or degree Celsius can be converted into Fahrenheit by using these two formulas. I would advise you to learn these two formulas, because some numericals are based on these formulas, and these are going to come in your exams. Now comes another topic, that is the transfer of heat. Transfer of heat means when there are two objects, and these are means they can be object number A or B. They can be they are put on different means they are at distance of each other. So heat can pass from other one to other. That process is known as the energy which is transferring from one object to other object through different ways, is known as transfer of heat. So now I'm gonna discuss with you the transfer of heat, means different modes or different ways by which the heat is transferred from one point to the other point. So there is first one which is known as conduction. Conduction is basically a mode of transfer of heat in which means the heat energy transfers from one region, means the high temperature, to lower temperature. Okay, and this occurs in the case of solids. Because if we talk about the solids, so you just recall the structure of the solids. It just see, it is a kind of a metal ball, and it inside that all the molecules are in the close contact with each other. So if we are heating it from this side, there is, means we are providing one, we are lighting a lighter or a matchstick here, then what will happen, this particle will gain the energy, and it will start vibrating, means there is some little much of vibration. So it will transfer its heat to this particle, 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 and in the same manner it will move from this particle to the upper, means the lower region to the upper region. So this is a kind of mode of transfer of heat, in which occurs in the case of the solids, because the solids are rigid, their structure, means there are there is no molecular space. That is why the molecule, means the solids can be heated up due to the conduction. So depending upon that, there are good conductors of heat or bad conductors of heat. Good conductors of heat are the one by through which the heat can pass from one region to the second region very easily. So these are known as good conductors, like all the metals are good conductors, aluminium, iron, etc. And bad conductors of heat are the one through which heat cannot travel at all. So these are the poor conductors or insulators. Example of such objects are like papers, wood, plastics. These are the bad conductors of heat. So there are some means applications of the good conductors of heat, like the all the cooking utensils are made up of metals, because these are good conductors. Mercury, which is a good conductor of heat, it is used in the thermometer. Other than that, in refrigerators or air conditioner, they have calling, means copper coils is present, so that it will gain the energy, and it will keep the things cool as it is. And other than that, in the water radiators, this you will see in the case of some cars or some of the heavy engines, they have radiators which actually keep the engine hot for a while. So that is made up of metals. Other than that, bad conductors are also useful, like in case of the means the handles of the utensils are made up of bad conductors. Other than that, thermocol is an insulator, so it is used in like ice box is made up of thermocol, so that their heat, and means their heat energy will, or they will remain cool as it is. In your water cooler, it has a kind of thermocol in between the sheets. And for storing the tanks, it is made up of plastic or glass. In winters, if you think about that, you use quilts or the blankets, because these wool is a bad conductor of heat, so it will absorb all the heat, and you will feel warm all the time. So these are some of the reasons why we use there is a application of bad conductors of heat. If you think about the conduction of heat through the liquids, it is not going to occur. Conduction of heat through the air, it is not going to occur, because conduction of heat never takes place in the liquids and the gases. Now, let us discuss about the convection. Convection is a process in which there should be a movement of the particles. Like, means particles should be free to move. There are so many particles present here and there, and if we are heating it like from this side, then what will happen, this particle will gain the energy, and it will move to other side. And from the upper side, the particles will move inside, then this particle will move inside, this side and this side. So in this case, this kind of circulation is known as convection, current. So particles will keep on moving and they will pass their energy to the other one, and in that manner all the container will be heated up. So this kind of thing occurs in the case of convection. Convection is possible in the case of gases and the liquids, because in case of gases and liquids, the particles are free to move from one region to other because there is intermolecular space. So there is application of the convection, like in case of, see this one, like in case this you have studied in your geography also, land breeze and sea breeze. So sea breezes are the one which occurs during the daytime. What happens, the land is warm, so the when the means the land is warm, so the air here will heat up and it will move to the side which is the that is what you say, it is to the towards the sea, and the water which is warm at this time, so it will means it will move from this side to this side, means from sea to the land. So this kind of the breeze is known as is known as sea breeze, which moves from the sea to the land. On the other hand, during the night time, what happens, because the air here means the sea water is warm, so it will start moving upside. The vapors along with the air will start moving upside, and they will start moving towards the land, because here the land is going to cool, sand is going to cool, and that air will move from land to the sea. So that breeze or that air is known as land breeze, which moves from the land to the sea during the time of night. So this is one application of the convection current. Other is your ventilators. If you see in your houses, there is means the windows are given, other than that one ventilator is given upside. Ventilator or exhaust is means exhaust is installed here. So this is why, because inside the your sorry inside the room there is warm air, and once the warm air rises upside, then it will move towards the floor. So if it is ventilators are given there, then that warm air will start moving outside, and you will means all the warm air will be removed. So this is another use of the ventilation means convection current. There is one more thing which is known as thermals. Thermals are basically the kind of the warm air which rise during the daytime, because during the daytime the earth is quite warm, so the air starts rising up, and on that this rising air is known as thermal, on which the birds can easily fly without even flapping their wings. So this is another use of the thermals. This you have seen in the case of eagles. They start means they without flapping their wings, they easily fly in the sky. Then comes the radiation. Radiation is a kind of the heat transfer mode which needs no medium. Okay, means it neither in the solids nor in the liquids, not in the gases. It does not require any kind of medium. Only means it can reach from the source to the destination without any medium. Example of this one is the radiations which reach from the sun to the earth. Okay, earth and sun, you see how much distance is there, and still the radiations or the wave energy which is present here comes to the earth without any medium. Okay, because you know that in universe there is no atmosphere, and still it is coming on your earth. So that means there is one more mode of the heat transfer that which can occur without any medium. So radiation of the heat actually depends on some of the things, that is the temperature of the object. If the temperature is hot, then it will radiate more energy. The surface area, the larger the surface area, the more radiations it will radiate, it will release. And distance between the two sources, if two sources are at far distance, then their radiations will be less. If two sources are near, then radiations will be more. And that is the reason that the planets which are near to the sun are means there the temperature is more, because they are getting more radiations of the sun. And on the nature of the surface, because if you are talking about the black surfaces absorb more heat, while the shiny surfaces absorb the less heat, and they radiate it also. So this is the reason there is some practice, means practical applications of the radiation also. So in summer, you have seen that you always wear white colored or light colored clothes, because light colors clothes absorb less heat, and they radiate, they reflect it back. That is the reason we use it there. Other than that, cooking vessels are highly polished. Vessels are highly polished, so that they will radiate very less heat from their surfaces. Okay. And teapot means polishing is the same thing. Other than that, all the pipes of the cars are made up of black things, so that they can absorb more and more heat, and it is for the limited time. And means you have seen the milk vans are mostly light in color, so that the milk which needs lesser temperature, it will remain in the lesser temperature only. There is one more application which is known as thermos flask. Thermos flask actually uses all the three kinds of modes of transmission of heat are looked around, so to make the thermos flask. So first of all, the thermos flask is made up of two walls, the outer and the inner, and inside these two walls it is filled with the some insulating materials like thermocoals. And this actually reduces the loss of heat due to conduction and convection, because if two objects are in close contact, then the heat energy will flow outside, so it stops that also. And its inner walls are highly polished, so that the loss of heat can be prevented due to the radiations also. And if you see, the mouth of the thermos flask is covered with a cork which is closely tight, so that no heat can come out of the this vessel. So this is the reason, if you are putting anything on the thermos flask, it will remain as it is. Either it is cool or either it is hot, it will remain as it is. So now if you think about these things, that dark colors are worn because these absorb more heat. If it is winters, you will wear dark colors, and dark colors also radiate more heat. And if you're talking about the light colors, colors absorb less heat, so that is why we wear it in the summers. And these also radiate less heat. So this is how your temperature I mean sorry sorry extremely sorry your chapter is completed. Now if you have any query, you can ask in the class. I'll give you homework depending of this chapter and during the class. Thank you, class.